Hi, my name is Florian Deisenberg. I'm one of the co-founders of CQSE. In this video, I'd like to demonstrate Teamscale's new improved search functionality by explaining how it can support a number of different use cases. As a demonstration object, in this video I'll be using Pixelitor. Pixelitor is an open source image editor that supports the functionality that you would expect. So you can load images, you can save images, and of course you can also edit images. Pixelitor is implemented in Java, and I've already loaded its source code into Teamscale. You can see that with about 120,000 source lines of code, it's not a large system, but it's not a small system either. Let's imagine you want to add support for a new image format to Pixelitor. You probably do that by first trying to understand how image formats are generally supported in Pixelitor. And to get to that, you could just search the source code for one of the image formats you know it already supports. In Teamscale, you could, for example, just enter the search term PNG in the search box, and Teamscale would show you on the first tab where it found files that contain the search term PNG in their file name, like the PNG file sequence writer, for example. On the second tab, and I'll get to that in a minute, it would show you code where the search term was found. And on the third and fourth tab, it would show you commit messages or ticket descriptions, for examples, where the search term was found, if this Teamscale instance was connected to the version control system or the ticket management system of Pixelitor, which it isn't for this demonstration. Let's take a look at the code tab. On the code tab, you see a visual representation of the source code and the search result. This is a tree map where each rectangle corresponds to one source code file. The size of the rectangles are determined by the size of the files measured in lines of code. Directory tree structure is also taken into account in the sense that if two files are close to each other in the directory tree, they're also close to each other in that visualization. And the color is used to indicate the files where at least one instance of the search term was found. So all the blue files contain our search term PNG. Below the tree map, there's a preview of the search results. As you can see, our search term PNG was mainly found in comments in the code. And this is actually a problem I often encountered when I used search functionality to search for specific concepts in the source code. Because obviously, these search hits don't help me to identify the places where there is some implementation about the PNG format in that case, but they just merely tell me that there is some specific file used or reference from a comment. And this is where the advanced search that we've newly introduced with Teamscale comes in, because it allows us to actually focus on our search on specific type of source code tokens. I can switch to the advanced search by selecting it here in the dialog. And after carrying out the search, you see that the results look similar to what we've seen earlier. So I have a tree map and I have a preview of the individual search results. But there's an interesting hint here that points out that my search term looks like I'm not using a regular expression. And that is one of the core features of the new advanced search, that I can use the full power of regular expressions. I can demonstrate that by just including, for example, .star here, carrying out the search again, and seeing a number of hits down here that, of course, all start with PNG and are followed by whatever source code that comes after that. By opening up one of those hits within a new tab, I'll see that I still have the problem that the result was found within a code comment, although I explained earlier that I would rather want to search for things that are not in comments. And this is the second core feature of the advanced search. I can select the type of tokens that I want to search in. So you can see in that dialog, I can select either literals, keywords, identifiers, or any combination of that, or I can just use that shortcut by clicking on all except comments. That deselects the comments. And now if I carry out the search, it searches the source code but excludes the comments from the search. So if you look at the search results down here, and if I pick whatever example here and open up a new window, you see that now I still have, of course, the correct match for PNG in the source code, but this is an example that is not from a comment. Again, this is probably not as helpful as we would have expected, but it doesn't really point us to a place where there's an actual implementation of the image format PNG, but it rather points us to a place where an image probably for an icon is loaded. To also deal with that problem, I can either limit my search to other types of tokens, for example, by excluding literals, like the string literal here, from the search, or I could even use more complex regular expressions just to demonstrate how something like this could look like. For example, I could use a regular expression that actually has a negative look behind in it, so it would tell the search to look for PNG only in the places where it's not preceded by that format that starts with icon and then has 2 or 3 digits, just to demonstrate that these regular expressions can actually be quite complex. What I would probably also do in that case is I would not only be looking for PNG, but maybe also for other file formats as well. For example, I can use the order operator of regular expressions to also use search for other formats like GIF, for example, or JPEGs, followed by any other characters in the source code. And I can also make sure these results are found no matter if there are small or capital case by including a so-called embedded flag expression that tells the search engine to ignore the casing. When looking at the search results, that large file on the top right here raises my attention. Hovering over it, I see that this is actually a test case. It's called assert JSwing test, and it resides in source test. So while this might in specific cases be helpful for my understanding of the implementation of file formats, in that case, for demonstration purposes, I don't want to look into the test code, but only focuses on the things that are actually in the application code. I can do that in the search by selecting a specific path I want to search in. In that case, it's quite simple because the source code structure follows established standards here. I can just go to the source folder and just select the main part that usually contains the application code and carry out the search for this part of the source code only by simply rerunning it. And obviously I will also get a different tree map here now because a different set of files will be included. But this allows me to drill down to specific areas of the source code I'm most interested in. Interestingly, I can do this drill down not only on the basis of the actual directory structure of the source code tree, but I can also do it on the basis of architectural components defined by Teamscale's architecture editor. For example, if I'm a software architect and I want to understand if this concept of file formats is something that is only present on the application logic layer or also on the UI layer, I could create a very simple architecture just for demonstration purposes here that breaks down the system into 2 parts, one that has to do with the UI and the other part that doesn't. I have to admit that I don't know much about Pixeliter's architecture, so I just pick something here that sounds promising based on the package name. So there's a package called GUI that probably belongs to the GUI. There's one called menus that I also assume has to do something with the UI. And I'll just leave it like this and create a second component where I just include everything else that I, for this reason, also simply call other. It includes all the code that is not part of the GUI component created earlier. I save that architecture, just simply call it GUI, tell it to not create findings for architecture violations because it's just for modularization or modeling purposes here, and use that as a basis for the same search by going back to the advanced search, entering the same search term here, and now selecting the part of the architecture that we just modeled. So here in the path selection, I can not only select actual directory paths, but also an architecture, now the GUI architecture, and now, for example, I can select the part that I modeled earlier called GUI and search only within that specific part. And of course, turning on or turning off the search and comments as well. So you see that the tree map looks a lot different because, of course, there's less code in there, but it helped me to focus my search on a specific architecturally relevant part of the system that I can define, of course, also with a lot more complex architectures than the ones that you just saw, by using Teamscale's architecture modeling feature. And I think that's a very interesting and powerful interplay between these two features, architecture modeling and search, as I can now combine them to search for specific terms in specific parts of the architecture, or even for finding out if specific architectural ideas like layering are actually adhered to or not. I hope this video gave you an idea how software developers and architects can use Teamscale's new search functionality to search for complex patterns within large code bases. If that is something that is also relevant for your work, please go ahead, download Teamscale's trial version and try it on your own code base.